Welcome to the TOEFL listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Professor Morales. Thanks for meeting with me during office hours to talk about remote sensing in site discovery.
Good afternoon, Mark. No problem at all. What aspect of remote sensing are you focusing on for your research on detecting ancient settlements?
I want to compare satellite imagery and LIDAR for finding ruins, especially in forested and arid environments. I am not sure which methods to prioritize.
That is a good comparison. Satellite imagery and LIDAR serve complementary roles. Satellite data is excellent for broad spectral analysis and temporal monitoring, while LIDAR excels at revealing micro-topography beneath vegetation.
Could you explain why LIDAR performs better in forested areas?
Airborne LIDAR emits laser pulses that produce point clouds. Some pulses penetrate gaps in the canopy and return from the ground, allowing us to create a bare earth model. That model can show low mounds, terraces, and ancient road alignments that are invisible in optical images.
So the canopy penetration is the key. Is there a particular case study you recommend I read about?
Yes, the discoveries in the Maya lowlands are a classic example. Researchers used airborne LIDAR to map entire landscapes under dense jungle and found thousands of structures and causeways previously unknown.
I have heard about Angkor as well. Was that LIDAR too?
Exactly. LIDAR around Angkor revealed the full extent of urban planning and water management features. Those insights changed interpretations about population and landscape engineering.
What about satellite imagery then? When is it more useful than LIDAR?
Satellite imagery, especially multispectral and hyperspectral sensors, is powerful for detecting soil and vegetation anomalies. Thermal infrared can highlight buried structures through differences in heat retention. Also, satellites cover large areas repeatedly, which helps with change detection and seasonal crop marks.
Could you clarify what crop marks are, and how satellites detect them?
Crop marks are variations in plant growth caused by buried features like walls or ditches that affect soil, moisture, and nutrients. Multispectral images can show these differences, often using vegetation indices, such as NDVI, to make subtle contrasts more visible.
I see. So satellite data can detect subsurface features indirectly through vegetation and soil response.
Yes, and remember there are trade-offs. Spatial resolution matters. Landsat and Sentinel offer free multispectral data with moderate resolution, while commercial satellites like Worldview provide very high spatial resolution, but at a cost.
You mentioned thermal infrared. Does that work in dry deserts as well as in temperate zones?
Thermal methods can be effective in arid environments because temperature contrasts are pronounced. In deserts, buried architecture can alter surface thermal properties, so thermal bands can highlight anomalies at certain times of day.
Are there times or seasons when satellite imagery is best for detecting features?
Seasonality is important. After rain in arid zones, soil moisture differences are more visible. In agricultural areas, specific crop growth stages produce clear crop marks. For forested sites, you often need dry seasons when understory visibility improves.
Back to LIDAR processing. What steps are required to transform raw point clouds into maps archaeologists can use?
Processing includes classification of points into ground and non-ground returns, filtering vegetation, generating digital elevation models, and hillshade or slope analysis to accentuate subtle relief. There are also canopy removal algorithms to produce a bare earth model.
We usually use canopy removal algorithms to create a bare earth model that reveals subtle platform edges and roads.
Exactly, and then you apply visualization techniques such as multiple hillshades, local relief models, and openness to expose different types of features.
What about false positives? How do we avoid mistaking natural features for ruins?
That is a common issue. We combine multiple data sources, for example LIDAR with multispectral imagery, and use expert interpretation together with machine learning classification to reduce errors. But remote sensing findings still require ground truthing to confirm interpretation.
When you say ground truthing, you mean survey and excavation.
Yes, systematic field survey, test trenches or coring depending on the site. Remote sensing narrows targets and increases efficiency, but it does not replace field verification.
Are there recent methodological advances I should learn for my thesis?
Definitely learn point cloud classification tools and machine learning workflows for feature detection. Also become familiar with open data such as Sentinel-2 and Landsat, and with cloud platforms that host imagery and process large data sets.
What about ethical concerns? I worry about publishing high-resolution locations of newly found sites.
That is an important point. Precise locations can increase looting risk. Many researchers use controlled access, embargoes, or generalized maps when publishing. Data sharing agreements with local heritage authorities are essential.
How expensive is LIDAR compared to satellite data for a graduate project?
Airborne LIDAR campaigns are relatively expensive. Costs depend on area size and flight logistics. Satellite imagery can be free or low cost depending on resolution. Many projects combine free satellite data with targeted LIDAR funded by grants.
To summarize, satellite imagery is best for spectral and temporal analysis across wide areas, while LIDAR is crucial for revealing topography beneath vegetation and mapping microfeatures.
Exactly. Your thesis could use both. Use satellite datasets to identify potential anomalies, then target limited LIDAR or drone surveys, and always plan ground verification in collaboration with local authorities.
Thank you. That helps me refine my methodology and the literature I need to review.
Good. Send me a draft of your methodology and the case studies you want to include. We can discuss specific datasets and processing scripts next week.
Will do. Thanks again for your time and the LIDAR and satellite reading suggestions.
You are welcome, Mark. And remember, ethical handling of location data is as important as methodological rigor.
Listen again to part of the conversation. Then answer the question.
We usually use canopy removal algorithms to create a bare earth model that reveals subtle platform edges and roads.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.